there's nothing like going into a classroom and seeing some little kid's face light up. I did it, I made it. It really works. It's super important to educate everybody about science because there's a lot of problems to solve, and that's what engineering is about, solving problems. So we want more people to come and help solve the problems and maybe solve some of the ones that we created. I work in photonics, which is applying light to solve engineering problems, and one of my problems that I'm really interested in is phased array antennas. My dad was an electrical engineer, and he encouraged all of my siblings and me to engage with science. I remember one Christmas he gave me an 8-foot weather balloon. I ended up using it in a science project in the 9th grade. I actually launched it, and he helped me. Since 2008, I've headed the K-12 Engineering Outreach Program, and by the end of this week, we will have reached 33,000 students. The idea is that we go to schools, after-school programs, scout groups, basically anybody who asks, and we bring hands-on engineering projects. They're not science experiments. They learn a piece of science and then they apply it to build a working widget, a speaker, a motor, a flashlight, what have you.
Oh, holy tamale, it works.
We focus on underserved communities, and we're looking to build diversity in the profession, but also we just love to go see little kids and do fun things. Today we're going to go to the Columbus After School All-Stars and do a great project with an electromagnetic jumping jack toy. We've noticed that some kids who don't excel in a normal classroom environment will just go nuts when they have this hands-on opportunity to build something, and teachers have remarked on it too. I regularly meet with some of my student volunteers so we can develop new ideas. We spend a lot of time designing our projects to make sure that the kids will be successful, because a lot of these kids I've noticed have not had many opportunities to use their hands at all, and they're afraid to.
Yeah. There it goes.
And we have found that for those kids, it is super important to be able to keep something, to have something that they can build and take home. So we work really hard to design all of our projects to be really inexpensive, less than $1 per kid. We try not to dumb down the experiments. What they're doing is they're learning a scientific principle and then they're applying it. So right before their eyes, the principle is applied, and all of a sudden they understand how electromagnetism can make a motor or a circuit can make a light. These experiences that they have doing things with their hands and being successful, and I can do this, is really important to build self-confidence, and if I can do this, I can take on the next thing. And you're going to take this battery right across the